Welcome back to A320 Knowledge, your trusted source for Airbus expertise. Today, we're diving into Airbus's guidance on how to manage fuel balancing.
I would like to first give you some background to the origin of this presentation. As you know, Airbus constantly monitors and analyzes in-service events. In 2016, there were 3 in-service events reported to us. 2 of these events experienced engine spool down in flight. And one of the events was related to low fuel level in the feed tanks at landing, which ultimately led to the engine shutting down. The investigations into the cause to these events showed us that 2 of the events were due to an incorrect management of the crossfeed valves, and one of the events was due to the flight crew performing a fuel transfer despite there being a fuel leak. Now, investigations made into the cause of the events showed us that there was one common denominator. That common denominator told us they were all linked to the incorrect application of the fuel manual balancing procedure. Now, our flight operations documentation already includes information about fuel rebalancing. However, because of these recent events, we believe that it is interesting for you that we make a reminder about the appropriate management of a fuel imbalance in order to avoid future events. So this presentation will be split into 4 parts. First, we will recall what can lead to an imbalance. Then, together, we'll review what are the possible consequences of this imbalance. Thirdly, we will then focus on how the fuel imbalance can be detected. And in the last section, we will recall when an imbalance is detected, how can the flight crew decide if the imbalance must be manually corrected. So let's start with looking at what causes a fuel imbalance. The first possibility as to why you may have a fuel imbalance can come from a direct cause. The most predictable one is a fuel leak that can be due to an external issue, because of a structural issue or a pipe failure, or related to an internal issue, that is a pipe failure inside a tank. Another cause that induces a fuel imbalance is a failure of the fuel system. It can be the failure of one or several fuel pumps inside a fuel tank, which traps the corresponding fuel. Or it can also be due to the failure of the fuel transfer system that leads to an unequally performed fuel transfer. Fuel imbalance can also be the result of indirect causes. This means that a specific aircraft failure or configuration can imply flight crew's actions that will afterwards create an imbalance. This is the case if an engine shuts down because it has failed, or because the corresponding feed tank pumps have failed above the gravity level. If this happens, the fuel of the tank associated to the engine is no longer used, and this will progressively create an imbalance. An imbalance may also occur for some cases of MMEL dispatch with fuel system inoperative components, as is the case on this A380 example. Finally, the cause to your fuel imbalance may not be linked to any failure at all. Sometimes the fuel consumption is not equal because one engine is older and needs more fuel to provide the same amount of thrust, or one pump can be less efficient than the others and the fuel of the corresponding tank is less used during the cross-feed actions. Specific operations on ground or in flight can also affect your fuel balance. For example, an imbalance may be a result of reduced engine taxi operations on ground, or it could be a result of using the APU on ground for a long period of time. It may even be a result of performing a three-engine ferry flight. So they were the different causes that could generate a fuel imbalance. But when is it really necessary or useful to perform a manual rebalance? Let's first look at the severity of these consequences in order to be able to correctly answer this question. So the first consequence of an imbalance is an increase of the fuel consumption during the flight. When the fuel repartition is no longer symmetrical, the ailerons and spoilers deflect to compensate the imbalance in order to ensure the trajectory. This deflection induces more drag, which, as you guessed, impacts the consumption of fuel. The second consequence is related to aircraft handling. Now, we saw that the ailerons and the spoilers deflect to compensate for the imbalance. And when this happens, there is less deflection movement available for the corresponding surfaces for the usual handling of the aircraft. However, rest assured, we would like to clarify that whatever the level of fuel imbalance, the handling qualities do remain guaranteed. The last consequence is the potential impact on the required fuel on board. When you have an imbalance, the fuel may be unevenly distributed. If you do nothing to change the situation, you may have a fuel low-level alert when getting closer to the destination, even if the total fuel on board seems to comply with the mission. If the fuel low-level alert is triggered on the ECAM, the procedure associated to the alert mainly asks you to open the crossfeeds. However, the downside of this alert is that it may be triggered very late in the flight when the crew workload may be much higher. So they were the three possible consequences. Now again, the same question. When is it really necessary or useful to perform a manual rebalancing? Well, to answer this question correctly, let's first take a look at the possible detection loops that will hint to you that you have an imbalance or that you may in the immediate future have an imbalance. The first possible way you can detect that there is an imbalance is when you have an ECAM alert. Such an alert only exists for the A340-500, A340-600, A380 and A350. When you get this alert, the lowest fuel quantity is amber underlined on the fuel SD page. The threshold of these ECAM alerts depends on the type of aircraft and is in line with the limitations of the fuel imbalance included in the manuals. When displayed, such alerts include a read and do procedure with sensed action lines adapted to each case of imbalance. Another possibility to detect an imbalance is when you get an advisory. This replaces the ECAM alert that we have just seen for the A320, A330 and A340 aircraft family. In such a case, the fuel SD page automatically pops up and the fuel quantity of the heaviest tank will flash. As for the ECAM alerts on the other aircraft, the threshold for the advisory depends on the type of aircraft and is in line with the maximum acceptable imbalance. As you can see, with an advisory, there is no direct action requested. The advisory simply warns the flight crew of the situation at hand and enables them to be ready or to start to prepare for a future possible action. Another way to detect a fuel imbalance is when you get an ECAM alert, initially not dedicated to the imbalance, but that includes actions to anticipate the situation. For these alerts, there are two possibilities. The procedure may include direct actions to avoid the imbalance. For example, this is the case for the engine shutdown procedure on the A320. Or the procedure may include information that a future imbalance is possible. In such a case, it is up to the flight crew to decide if they want to rebalance or not. This is the case for these two examples of the outer tank fault on the A380 and the electrical busbar fault on the A340. The last means to detect a possible development of imbalance is via the application of the SOPs during cruise. Now, as you know, the cruise SOPs include a periodical check of all SD pages. For the fuel SD page, the flight crew should check both fuel quantities and distribution. This check is applicable to all Airbus programs, and it enables you to anticipate the fuel imbalance. Note that if the flight crew do suspect that the imbalance is beginning, or is likely to begin, we do recommend that you increase the frequency of this check. So we have seen that to detect an imbalance, we can use ECAM alerts, dedicated or not, advisories, and cruise SOPs. But once again, when is it really necessary or useful to perform a manual rebalance? I think we are now ready to answer this question. The first rule you must know is that you should never start to rebalance the fuel if a fuel leak is suspected. This may be an obvious statement, but one of the 2016 events reported to us was due to rebalancing despite there being a fuel leak. And the consequence was a fuel low level alert, and the aircraft landed with the fuel on board being well below the required reserves. The reason for this advice is that there could be a risk of fuel starvation. To detect a fuel leak, we provide you with some guidelines. Guidelines via the ECAM alerts. And guidelines in the FCTM. There are some techniques of evaluation for detecting a fuel leak in the FCTM. When the flight crew is sure that there is no fuel leak, they should always apply any sensed ECAM alert. As a reminder, such alerts only exist on the A340-500, A340-600, A380 and A350. When you get this alert, there is no need to evaluate it. You can apply the read and do actions. If you have a dedicated ECAM advisory appear, such as is the case on the A330, A320 and A340, the flight crew can consider applying the rebalancing procedure via the QRH. Now, then we have the case where the flight crew will need to consider applying a non-sense procedure, that is the ECAM or the QRH. This is the case if an advisory is triggered, or when a non-dedicated ECAM alert informs that the risk of a future imbalance, or even when the flight crew detects the start of imbalance by the SOP checks. The principal reason as to why the flight crew would go ahead and take the decision to rebalance the fuel is to essentially optimize the fuel savings or optimize the workload. Now, this critical decision is based on an assessment of many different criteria. These criteria includes asking the question, Is there still enough fuel to complete the mission? Is there a risk to have a fuel low level alert close to the destination? Depending on the current and planned workload, when is the best moment to concentrate on the rebalance? The procedure may be complex on some programs, such as is the case on the A380. The complexity and time to perform the procedure should be taken into account. As an example, in one of the events reported to us last year, in 2016, the flight crew applied the procedure so many times that at the end they did it by memory, and they missed an essential step. Another criteria to take into account is the operator's policy regarding fuel savings. Is the balancing really necessary? And finally, on ground, is the aircraft allowed to take off with that kind of imbalance? Now, if the decision is yes, let's rebalance. The first principle when you decide to perform a manual rebalance is to apply the ECAM or the QRH procedure. Do not perform the procedure by memory, even if you have the feeling that you know it by heart. This may seem obvious, but one of the events reported to us was linked to some errors in the steps of the procedure. Take advantage of the procedures at hand and use the material available to you. Let's take a look at one example of a manual rebalancing procedure. I would like to remind you of the right order the actions should be performed in. So when you start this rebalancing, it is important to first open the crossfeed valves and then shut the fuel pumps off. At the end of the rebalancing, it is the inverse. It is important to first set the fuel pumps on and then close the crossfeed valves. Also note that the number of crossfeed valves to be opened depends on the aircraft type. For a twin-engine aircraft, one crossfeed valve must be opened. For four-engine aircraft, at least two crossfeed valves must be operated to interconnect the feed tanks. This essentially assures that pressurized fuel is always provided to the engines to allow continuous correct operation, in particular above the engine gravity ceiling. As a reminder, in 2016, 2 events of engine spool down were directly linked to such misuses of the procedure. So it is important to avoid applying the procedure by memory. To conclude, we have reviewed together how an imbalance can be detected. You know you will either have an amber ECAM alert or you will have an advisory. There may even be a link in a non-dedicated ECAM procedure. Alternatively, you may notice the imbalance via your SOP checks. If there is an imbalance and you choose to rebalance the fuel, do not do so if you have a fuel leak. Provided there is no fuel leak, you should always apply the procedure when there is a dedicated ECAM sense procedure. In all other cases, it is the flight crew's decision. If the decision taken is to rebalance, do not act from memory. Use the procedure on the ECAM or in the QRH. And finally, respect the number and order of actions.
Our popular A320 tech quizzes are now part of an exclusive newsletter membership designed to provide you with even more value. As a member, you'll receive 4 brand new A320 tech quizzes every month, one each Monday, delivered straight to your inbox. You'll also receive exclusive deep dives into A320 systems, procedures, and techniques that go beyond this YouTube content. And you'll also gain access to bonus content and other surprises to keep your knowledge fresh and up to date. If you're interested, Click the link in the description or scan the QR code on screen to sign up today. Thanks for tuning in, and let's take your A320 knowledge to the next level.